this presentation is about scriptless testing, a really exciting topic, I think. But let's start with a statement that we as a small team at ING strongly believe in, and that engineers like you are at the heart of IT innovation. And we want to hear your ideas on how to be more effective in your daily job or the challenges you face. Well, we also understand that it's hard to be innovative and also do your daily job at the same time. So that's where our team comes in. Of course, we're not, doing all the innovation that what's in your focus, but this picture of our team, and this was taken at the online Christmas event. As you know, ING also, most of the IT people were working at home. So also the team events were at home. It was really fun, great fun. We have 5 fixed team members. That is Luna Japing, Kevin van der Vlis, Tim Soethout, and Anna Monalachi, and myself. And all of us have a strong engineering background with masters and PhDs in software engineering. And if you look closely, you can spot David in the top left, while I'm a bit squashed at the bottom right. So what do we do? Well, we actually collaborate with a lot of universities, Dutch universities like TU Delft, Eindhoven, Open University. And we also host a lot of students doing master projects with us. I will explain later why we're doing that. And some of them were present in the previous slide, so I didn't pronounce all the names, but that's, every 6 months we have a new set of more or less students. So, but we have a fixed team of 5. Next to that, we also host IT class students. And these are our next-gen high potential IT candidates that we want to recruit at ING. And one example of that is actually David, who joined ING in June after he did a master's with us. So we're very happy to have him. And of course, our team doesn't work in isolation, as we collaborate with other teams and chapters at ING to collect and solve challenges. So, So actually, people are really happy, collaborating with us, and we also like to collaborate with them, as you can see in the quotes. So now, what's our way of working? Well, it all starts with collecting the challenges from squads in ING. So we're very close to the squads, and then we look at potential innovative solutions, and that can be come from academia or from industry, but we do a thorough literature study to see what's out there. And then if we find a solution, we are going to validate it with a proof of concept. And sometimes we build the POC ourselves, or if it's too big a challenge, then we open the student assignment, and then the student can really work on a problem, and we get a result there. And then we apply the POC in several pilots in different teams, different settings, because ING is a really big company, so you have to validate it in the different configurations, supported by chapter leads and team leads to validate our assumptions further. And after that, we present the results to management, and then it's up to management to decide whether to productize the initiative and maybe roll out a solution globally. But we're not a team that builds products. We advise management, really look at the challenge and also present a business case like, okay, if we do this, we really are more effective, more cost effective. So management is also interested, right, to reduce the costs. So now let's highlight one of our initiatives, which started out as a European project funded by the European Union, and we're part of that big project. So a lot of different parties, universities, corporates working together in a big project. It's EVE's project. We're now we just finished the second year of this project, and this is actually how we start looking at scripted testing. So the start is 2019, start of the European project. We set up a collaboration with the Open University on GUI-based testing using Testar. That's a tool that is developed by Open University. So we use their tool to validate the scripted testing at ING. So that was really nice. We also did a dissemination on AI-based testing, both inside ING and outside of ING. And we then worked on different use cases, in particularly the ING Flow web components. This is a generic framework we use for complicated user journeys. During that, our engineers learned more possibilities on AI-based GUI testing or scriptless testing. Additional result is, while we were doing the use cases, we were discussing how to make applications better testable by these kind of tools, because you also want to move your application towards a solution so your app can be tested in a more efficient way. So coming from both sides. Let's see. So why are we interested in this? Well, if you look at software, well, it's all over the place, right? Software is eating the world, or they also say machine learning is eating the world. But there's a lot of money spent on software, but there's also a lot of money being lost. And that's because of low quality software, right? And what's even worse, I would say, is that we also lose our customer trust by low quality software. So we're not the only ones, right? So if you look at here, I think it's a screenshot of Facebook. I think it's a mobile version. So I don't know about you, but I have a hard time understanding what's going on in terms of what are the prices and what are the titles. And I think on the left, it's an example of the Booking.com app, which is also not a very good user experience, I would say. It's not blocking users, it's not crashing, but it's also a bad user experience. So, there was this question already. Do you like GUI testing? So probably you already seen this pyramid, and of course, we use testing to keep a high standard. And when we test, we want to validate the security, reliability, and the quality of our software, right? And then we use 3 types of tests, typically. So we have the unit tests. These tests are really to validate small, isolated components. They're cheap, they're fast, and there are plenty of them. And then we have the service tests. That's actually where we validate the combination of components. And they're less isolated, but still relatively cheap to create and maintain. And then we have the GUI tests. And here we validate the end-to-end result. That's touching all the components, all the software. And these tend to be expensive. These tests are expensive to create. They're also slower. And we also typically don't have many of them. That's why it's a pyramid, right? It's less of them in the top of the pyramid. But our customers don't know about this pyramid. They only see the GUI. So it's all happening in the GUI, end to end. So how do we make sure that everything works correctly when we have not that many GUI tests, right? We have them, but not that many. We would like to have more of them to get more assurance, right? That our app is really creating this nice user experience. So what do? We manually test. That's not really scalable because manual tests are expensive, time-consuming, and non-repeatable. But don't underestimate the creativity of human testers to find issues. So at ING, we have a monthly break the app session where we all get in a room and we have when we do a big release with lots of new functionalities, we try to break the app. So we try to really, with our brains being smart, try to break it. So typically that's not something automated tests catch, these kind of usability issues or accessibility issues. The automated tests are created by an engineer. And what's really nice about it, that they're repeatable, and you can run them automatically. You get nice reports back when something is not correct, and then you can rerun. So this is like the modern way to do GUI testing. But there's one big issue with this, is that testing is really expensive, whether it's with testing scripts or manually. And it's actually estimated that 25% of the total IT budget is already spent on testing. It's a big chunk. And that's because test scripts have to be developed, maintained, run frequently. If you have lots of changes coming through the pipeline, you also have to update your tests. So there's a lot of work and effort being spent there. And why is that? Why is it so, why are we spending so much time there? Because I think one of the issues is that creating a good test script requires extensive domain knowledge. It also needs, you need to know the application, you need to know the frameworks, you need to know the testing tool. So it requires highly qualified people, but also domain knowledge. And what's also a problem is that it's not really mimicking, these automated tests are not really mimicking the random behavior of users. Because you're mostly testing the happy flows, but there are also many unhappy flows, hopefully not, but could be. So I think that is one of the key problems here, domain-specific knowledge and maintaining that. So there we have it, Scriptless GUI testing, finally. The solution to all your problems. No, not really, but it will help a lot. It will reduce the number of script-based tests. It will catch more issues because it's exploring the whole application. It's clicking through all the possible directions it can take. So it doesn't really replace functional tests, but it complements it. Right, so it's not going to replace functional testing, but complement it. Keep that in mind. So you could use it for functional testing, but then it would require, again, injecting domain knowledge into the monkey. We call it also monkey testing, by the way. And then, of course, you end up in the same situation. So again, it will be more expensive to maintain. All right, what and how? So now let me show you an example of the tester tool, which with an extension, ING extension on top of it, clicking through a mortgage calculator. So here it is. Mortgage calculator, it's something you can do when you go to the ING website and when it's a bit squashed, okay, fine. And when you want to apply for a mortgage, you can already use his mortgage calculator to calculate a possible offering. So here you can already see the monkey, I call it. Okay, it's, scripted testing is a really big word. So the monkey is clicking through the application randomly. And what you can see that it has a number of options. The green dots indicate all the options. And then it chooses randomly one of the options. It also has an option to put data into a input field. And as you can see, without any knowledge, so the monkey is really, it's a bit smart, but not that smart. It's already able to click through the mortgage calculator. And well, it's a big mortgage, 1.6 euro, but it's a big one. So another route. Now I'm speeding up the movie a bit. And now it takes another direction because it has memory of what it did the first time. So now it will go try another scenario, a test case scenario in that sense. And as you can see, now it's doing a different user journey, so to speak. And then, yeah, it's a bit more involved. So, and then, well, you understand how it works. And then we do that like 100 times. And then we try to catch software quality issues. So the monkey, so we know what's the software quality issue. But the monkey will just try to find it. Okay. Now this is a more involved one. So the previous one was pretty basic, I would say. But this one is actually much more involved. This is a COVID loan application, which was used by Belgium corporates to get a loan. Because of COVID, they were not getting the revenue. So here they could apply for Belgium a loan, but it's much more involved. So look, there's like a lot of options. Well, a whole sheet of monthly revenue streams. Well, still the monkey is able to get through this one and really advance to the next stage. So that's a quick preview of how tester or the monkey actually is being effectively testing a web application. So we use tester. So let's just explain a bit how it works. So on the one side, we have the system under test, which is an academic term for your application. And on the right, we have this tester tool, this open source tester tool. So what tester does, it first captures the state, which is the DOM, the complete DOM, also the shadow DOM, the whole state. And then it will take that state, store it. It will then check whether that state has any indication of issues. So an issue could be there's some accessibility issue, or there's some errors in the log of the browser. If there's no failure, then it will determine all the actionable elements, and then based on some really smart algorithm, or you can choose which one, it will choose one of the possible options. So this is where the AI bit comes in. So we use Q-learning. We use, I forgot the exact name. I think it was, I don't know. I don't remember. No, it's, I will come to that. But different AI techniques to make this action selection smarter. Because that's really, where you need to, where the monkey needs to be smart. Because if it just does it randomly, it will end in nowhere. It will just not advance. So here's the bit smart. But still, it doesn't require any domain knowledge. So let's get into a bit of theory here. So already told you that tester captures the state, and this state we call concrete state. So It could be like the login page, which is like the whole DOM. We captured all the buttons and the positions and their colors and the whole shebang. And then we have these multiple actions we can take. So if we take one of the actions, we end up in a new concrete state. And again. So these are all the possible options the monkey can take in terms of states. And you could say that the state is actually the GUI, a snapshot of the GUI. But there's, and then of course, if we run test_star indefinitely for like infinite time, we would catch eventually all the issues that are lurking in the application. But yeah, that's just not feasible because then we end up with this state space explosion, right? Like trillions of states. It's not really it's not realistic, right? This picture. So what do we do to kind of reduce the number of states? We have this notion of abstract states. And what it does, an abstract state is actually a concrete state where you throw away all the details that are irrelevant, like the position or the color of an element. That's not relevant for the monkey to be effective. So that's a bit of theory, but it's really crucial for the monkey to be able to abstract over the concrete states and look at the application in an abstract way. That means that a number of multiple concrete states are mapped to a single abstract state. That's kind of another way to formulate this concrete abstract state notion. And now we also have this component, this failure testing component, and the academic term for it is test oracle. And what it does, it just simply evaluates an abstract state to see if there's something wrong in terms of software quality. And then tester will assign it a severity. So when it has severity lower than 0.5, it will just continue, but it will report that in the final report that there is something is off, but it's not really fatal. And then we also have severity 1.0, and then the monkey stops. It will just say, this is really like, okay, let's stop. It's really not making sense to continue. Now, of course, what I already said, that if you have like tester, the monkey just doing everything randomly, it will be stuck. It won't be very effective. And that's what we experienced at ING. We took the tester tool and applied it on different applications. And then it didn't really work that well. So what we did is we built a rule language on top of it to make the monkey smarter. So it's again in this action selection tool, this brain like AI. Well, this is not AI, but it's rule-based AI, you could say. But of course, adding rules to the monkey means adding some knowledge into the monkey. So it's really, really important that we add rules that don't inject domain knowledge into the monkey. So it should be generic rules. So let's look at these rules. We have three types of rules: action priority rules, we have input generator rules, and we have Oracle verdict rules. And now it gets, first a bit about why we came up with these rules. So one of the things is that these rules should compose. Normally, if you look at test scripts, if you take two scripts, you cannot really compose the scripts unless you make a reusable, like a small sub user journey. But typically, test scripts don't compose. So that's really something. So we should, let's give it some knowledge, but this knowledge should really be composable. So that's a really strong property we want to have for this solution. And it should also be flexible in the sense that it should address many use cases. So we looked at some rules, and then probably if you're building GUI test scripts, you are already using CSS selectors or XPath selectors. We choose XPath XQuery as a language, but CSS selectors is also an option. We already exported, but it's not. We still need to do some work there. So now let's take an action priority rules and how they can be composed. Let's start with a simple input form. So we have a single text field. We have 4 options, exclusive, and 1 submit field. So if you don't use any prioritization, the tester will just randomly choose one of the 6 options. It also doesn't really have a memory, so next time it will again choose randomly one of the 6 options. Okay, but we already see that the Volvo has been selected, the option Volvo has been selected previously. So there's already some notion of something happened in the past. And we also see that the age field has a red box around it. So there's something wrong, it's invalid. So we have some rules, generic rules, that says, well, if there's something invalid, the text field or some other button, it's invalid, we raise the priority by a factor of 3. So it's a multiplicative priority. That means that the action the monkey will take will have a high probability to retry entering data in the age field. Then we have the second rule, and that's a bit more involved, but that's actually saying, hey, if I already clicked this thing once, I want to deprioritize the action. And if we look at number 3, that's really a rule saying the options are not inclusive, but exclusive. It's either Volvo, either Saab, either Opel, and not equally probable. So when we apply these rules, you already see that they're composing, because multiple rules can be applicable for a element. So if you look at the Volvo element, you see that the second and the third rule are actually applicable, and that's why the priority is 1 out of 8 instead of 1 out of 4. We also see the priority of your age being 3, and then the submit button is still 1. So if we calculate, the probability, you will see that when it randomly chooses an action, it will bias the your age field to enter some new data there. So that's something we built on top of Tester, and it's really effective. And we're still expanding on this. We also have input generate rules. So for the input fields, we have regular expressions that are actually formulas that describe what should be the input. And if we apply it on this field, we see, actually both rules are applicable. And if we apply it, we see that in 33% of the time, it will apply rule 1, and 66% of the time, it will apply rule 2. So there's still this randomness. It can still put random data in a field that's not feasible, but we want that because it could well be that your application is not correctly taking that into account, and it can crash your application. So you could say this rule system is actually a controlled randomness. But because we still want to be random, it's really important to explore the whole application, but not too random. So it's a trade-off. And then we have the Oracle verdict rules, where we capture possible issues. So here, the first rule is actually looking at the log, the browser log, to see if there are any severe log messages. And the other rule is just matching error statements in the page. But we are not stopping it, but we think it's suspicious then, right? But the first one really stops the sequence. Okay, a bit about the architecture. So we have the tester core layer, we have the ING generic layer and the specific layer, and they're all composable. So we leverage the genetic algorithm. There it is, the AI technique. And reinforcement learning components that are provided by tester. Then we build a generic layer on top of it that is really targeted towards standardized components. And then we have the ING specific layer that's really on a use case level specifically. So that's our architecture. And it's really going from generic to a bit more specific, but still we want to have this low maintenance, right? So we put some additional rules when we go to the specific layer, but it should be very generic. So we have this low maintenance. Okay, lessons learned. So we started using this proof of concept tester, and then the ING extension on top of it. Oh, sorry. So we tried 5 pilots, 3 of which we finished. And we found software quality issues during all pilots. Soft errors, more or less, not really big ones, but yeah, things are visually not correct or accessibility issues. And indeed, the rule configuration required low maintenance. So when we did a new release of the web app, we didn't have to change the rule configuration at all. So that's also a good sign. We still have challenges to be addressed, of course. The tool is built in Java, so it runs on the Java virtual machine, while the ecosystem of web development is Node.js. So that's a bit of a challenge to integrate them. But we have some ideas to alleviate that. Go fast or slow. Of course, we want the monkey to be as fast as possible, but not too fast, because sometimes the GUI is still waiting. Or so to detect whether the GUI is stable or not is really a challenge still. We have some ideas there, but it's a challenge to do it generically. And we also have, let me check, performance issues. So if there are a lot of widgets, like infinite scroll pages, then tester is also not really working that well with huge amount of widgets. And what about mobile? You can also use it for mobile. So we did a master thesis project. It was Thorn Janssen. He graduated cum laude on that, so that was really great. Tester doesn't provide it out of the box. And David actually continued with that, with the work of Thorn. So if you have any questions related to scriptless testing on mobile, David can probably answer them. So here's a small movie again, but then it's the ING mobile app. It's not the production app. It's running in a test environment. So the PIN code is 11111. So it's fake data, but yeah, the same approach also applies for mobile. But of course, you have some differences also. Hey? You have swipe, you have different gestures you don't have on the web. So that makes it a bit different. You also have a smaller screen. So it means you have to scroll more. So scrolling is also more important to incorporate that. But again, you can see that the monkeys also, testers also effective here. So that's another extension we built at ING. It's still a proof of concept, but we're advancing and we're getting there because also of David's work. So thank you for that, David. So what did we learn there? We did a mobile app experiment and we used a code coverage metric. So what we did, we took the script-based tests we currently have and we measured the code coverage, which was 44%. And then we used the scriptless solution and then we measured the code coverage and we end up with 41%. And interesting enough, if you combine both, you get a higher coverage. So that's really the getaway is that scriptless testing is not going to replace your script-based tests, but maybe a part of it. So where they overlap, I would say go for the scriptless solution because it's cheaper. That's the takeaway message. Okay. And then, yeah, of course, mobile is different. So Android and iOS, really different platforms. We try to make it like one solution for both, but it's really hard to do that. So we decided to do an Android track and an iOS track really disconnected. State identification, so abstraction, state abstraction is also a bit more difficult in the mobile compared to web. And it also, I would say that the tooling is less mature in the mobile for mobile than for web. And I want to summarize it's all about trade-offs. So it's all about engineering. So if you have a monkey that is really stupid and just clicks around, it doesn't really cover much of your application. But if you inject a bit of knowledge into the monkey, generic knowledge, then it will be much more effective. It will cover a lot of your application and while still being low maintenance. And this is the end of my presentation. I hope you enjoyed it.